Okay, so let's talk about 1, 2, 3, and 5 from the book. I have a big mess up here. Let's see. All right. So I'm going to go over all of them. I know you might not have questions over all of them, but just for the video purposes, I can have all the answers. Number 1 says, list 3 signs that could indicate a chemical reaction is taking place. What are 3 signs? What's 1?
The
Right.
temperature.
Temperature. Okay, I'm going to put that all together as energy released. If energy is being released, okay, through an increase in temperature or light or sound, okay, that would be an example. Devin, what's another one?
The creation of a gas.
Okay, gas created. And what's the other one, Quentin?
We got a physical change.
A physical change is not an example of a chemical reaction.
Like a change in color or something like that.
Change in color could be, but not always. All right, Maren, what's the other one?
A solid being created.
Okay, solid created, and by that we mean a new solid is created.
Like bread.
Okay. Number 2, identify whether each of the following is a chemical reaction. So is melting ice a chemical reaction?
No.
No, because it's still water, right? What about burning a candle?
Yes.
Yes, we know that because we know there's energy being released, plus there's gas created, you can smell it, right? Rusting iron,
Yes.
yes. Number 3, predict which atoms can be found in the products of the following reactions. The whole idea is whatever you start with, you have to end with. We're not going to talk about amounts yet, we'll talk about that later on. So if mercury oxide, mercury 2 oxide decomposes, you should end up with mercury and oxygen, okay? But mercury, comma, oxygen as the product. Limestone reacts to hydrochloric acid, you should end up with Ca, calcium, carbon, oxygen, hydrogen, and chlorine, all part of the product. Table sugar burns, you should end up with carbon, hydrogen, and oxygen, all part of the product. Anytime it says something is being burned, it means that oxygen is being added to it. That's what burning is, okay? The combining of oxygen. And then we didn't do 4, but number 5, we wanted to say whether these are exothermic or endothermic. Paper burns with a bright flame. What's that?
Exothermic.
Exoplastic. Becoming brittle after being left in the sun. Endothermic. Firecracker exploding. Exothermic. Okay, so on the page with the notes in your comp book, I'm going to give you a little web that will help you identify, if I can get it to show up, whether a chemical reaction is taking place. Okay, so chemical reaction clues.
This is on the same page as our notes today.
No, this is for the nature of chemical reactions. So put this like after the questions or whatever. Normally we would just put this on the left side. You wouldn't write things on the left side, but because of the way we had to do things this year, it didn't really matter. So chemical reaction clues would be formation of a solid, formation of a gas, release of light energy, release of sound energy. So take a second and put that in your comp book. I'm going to go take a roll. Actually, I can't do that. Well, maybe I can. So chemical reaction clues: formation of a gas, release of light energy, release of sound energy, and formation of a solid.
So it only has to be one of these to happen?
Yeah.
You-
Yeah.
So what
And there's
about-
other clues too, but these are the big ones.
So like As like boiling water, that technically creates a gas,
Yeah,
but that wouldn't be a chemical.
right, okay? Really what we're talking about is the formation of a new gas, a new substance, okay, that wasn't there before. Now, everybody always says, and I think this question comes up on the test, about a change in color, that a change in color is evidence of a chemical reaction. Well, it could be, but it doesn't have to be. Let me give you an example. If you take a piece of metal and you heat it up, it'll turn like red hot. It's changed color, but is it still the same metal? Yeah, so that would be an example where color change isn't, okay? So just because there's a color change does not always mean that a chemical reaction is taking place, and that's really why we didn't put that up here, okay? Because it's not good evidence of that. All right, so let's turn to yesterday's lab. And the first thing I want to do is fill out, fill out this data table. So let's go through and put all the numbers in there. So who had 3 pieces of zinc? So Wyatt, what was your mass of zinc used?
0.3.
Zinc remaining,
0.
product,
4.25.
that's a large product. And what's the ratio?
0.07.
Okay. I would say that you messed up this part here someplace. I don't know if you messed up on the massing of the evaporating dish, but something was wrong with this. It should have been a much smaller number. All right? On 4 pieces of zinc, who had that one? What did you get, Lucas? What was your mass of zinc used?
0.81,
Okay.
0.35,
All right.
0.46, 1.9, and then 0.46.
All right. 5 pieces.
We have 1.3, 0.76, 0.55, 1.93, and then 0.28.
Okay, I think this one might be wrong. Let me calculate that one. 0.46 divided by 1.9 is 0.24. Ella, what did you say it was? Your
We had 0.28.
okay, that's fine. That sounds right. What about 6 pieces of zinc?
2.01,
All right.
0.99, 1.02,
1.02. Okay.
2.13, and 0.48.
All right. 7 pieces of zinc.
I'm pretty sure we had 6. Like, we had 6 also.
We had 7.
We had 7? Oh, no, we had 6 the other day. Did you change it?
Should have been 7 if I counted right.
We had 7.
I
So
swear we had
what did you have? What were your numbers? We'll put it down here for 7. It doesn't really matter. All that matters is the mass
for 7,
for 7.
1.8,
Okay.
0.22, 1.06.
Now it should be these 2 things subtracted. So if did you say 0.22 for this?
Yeah.
So that's 1.58, I think. Doesn't that look right?
Yes.
Somebody tell me if I'm wrong. And then what's your product?
1.8.
And then your ratio?
I don't have the ratio.
All you have to do is 1.58 divided by 1.8. .88. Okay, and then 8 pieces of zinc.
We had 2.12,
All right.
1.19, 0.93, 1.79, and 0.52.
Okay, good. So have all those numbers written in your comp book, all that data. We can see that our biggest problem in here is you get through the experiment once. If you get to do it several times, if we would take a week and work on this, you'd end up with some pretty good numbers for your ratio because you'd see where you messed up, how to do it correctly, you get practice using the balance and so on. But doing it once, you don't get to correct your mistakes. So what the actual value should be is 0.48. There's one here that's right on. There's one that's very, very close too. All right, the rest of you, there's a lot of places you could mess up here, which we'll talk about as we go through this. Asher?
What's the ratio on I can't.
It's 0.28, sorry,
Okay.
0.28.
Thank you.
So let's talk about the blue questions. And I'm going to go over all of them, even though you probably don't need them all. All right? Just so I can get them all and put it on YouTube. Anybody that needs them. So, can I erase all this?
Hold on, not the last.
Okay.
You can erase the rest, but not the last.
Go ahead, write it in there. I'll just erase it all together.
Okay.
Got it? Abby, you got it?
Yeah.
Okay. All right, so let's talk about the blue questions first. The very first blue question says, which we did this one in class, what's the gas given off in the reaction? That was hydrogen, right? So the next one, why should you add the washing water to the evaporating dish? Any ideas? Remember, now let me back up and talk about what we meant here. We added all the stuff in the test tube to the evaporating dish except for the zinc, and then we washed it, and you were supposed to add that too. Why did you put it in there? Lucas, why did you put it in there?
So that it would wash all of the other substances off the zinc, and all you had left over was the zinc.
So what was in the washing water that we needed?
Zinc.
Well, we needed the zinc, but,
Acid.
Zinc.
well,
The
it was the
slippery.
product that we wanted to find at the end. So when you added the washing water, what you did is you washed all the zinc chloride, which is the product, off of the zinc and off of the sides of the test tube, and you got that in there too. And really, we probably should have washed it several times. And so I'm going to say, why should you add the washing water, the evaporating dish? I'm going to say it contained product. If you just dump it out, you're going to lose some of your product. You won't get that back at the end. And really, we probably should have done it a couple times, but it just takes too long to evaporate away 15 cubic centimeters of water as opposed to 10. How much metal react with hydrochloric acid? Whatever you got for the massive zinc reactant is what you're going to put there. Whatever your group got. Whatever that number was. Let me move this up a little bit. What's the ratio of the massive zinc reactant to the massive zinc chloride formed? I'm just going to put down what it should be. We said it should have been 0.48. So put should be 0.48 as the ratio. Compare your results to those of your classmates. The next test of either zinc or hydrochloric acid affect your results? No. Okay, it shouldn't have. Now, if you look at just your numbers, doing it one time, you would see yes, it did. But probably we had to do it again. And if we took all the class averages, I always have 3 or 4 groups that get right around 0.48. Okay, and there's always 3 or 4 groups that don't. 2 or 3 groups that don't. Just because of all the places you can mess up. If the zinc chloride, were not thoroughly or were not completely dry when massed, how would this affect your ratio? Well, let's write out the ratio equation. Okay, so the ratio is equal to mass. I'm just going to put zinc reacted divided by product. Now, there's a bunch of different ratios we could have done. This is just the one we picked. We could have compared hydrogen produced to hydrochloric acid that reacted, or zinc that reacted to hydrochloric acid used up. But this was the easiest one to do. That's why we picked this one, okay? It was really hard to tell how much gas you got. So if it wasn't completely dry, that means your product is going to be greater. So what's that going to do to your ratio? Decrease it. Okay, so that's the answer to blue question number 6. Your ratio would be less. So if you got a ratio less than 0.48, that could be the reason why. You didn't completely dry it. You didn't get rid of all the water. Then number 12 kind of asks, the same thing. That's kind of crooked, but it's the best I can do. It says, how would the mass ratio of zinc reactant to zinc chloride be affected if the zinc chloride were not thoroughly washed from the test tube into the evaporating dish? So let's write the equation again. So ratio is equal to zinc reacted divided by product. If it wasn't thoroughly washed, what's it going to do to the amount of product we have? Make it less or make it more?
Less.
Less, because you didn't get it all out, right? So you're going to have less product, and this is going to be what to your ratio?
Increase.
It's going to increase it. So number 12, the ratio, that could be a reason why it was above 0.48. Number 13, what would be the ratio of the zinc to zinc chloride if 5 grams of zinc reacted during experiment 6.4? It doesn't matter. It's still 0.48. Doesn't matter how much zinc we use or how much hydrochloric acid you use, the ratio is always going to be 0.48. Just like the ratio for water, the volume ratio was 2. The mass ratio was 0.13. It's what it always is. Which of the following calculations can you use to determine the mass of zinc chloride produced when 5 grams of zinc reacted? Well, let's look at the equation again. Here's the equation. Well, actually, here's the equation right here. I'm just going to put the numbers in. So we know the ratio is supposed to be 0.48. The mass is 5. And we're trying to solve for x. So how would you solve for x? Devin?
You would multiply each side by 1/5.
By 1/5?
Yes to, like,
Okay.
well,
I think you're on the right track.
It would be
I don't know if it'd be 1/5 though.
Just multiply 5 and.
Okay, so let me ask you this. Should this number be larger than, should this answer here, this x, should it be larger than 5 or smaller than 5? Larger. Okay, so if we do this, do you get a number larger than 5?
no.
No, you get like it's about 2.5 is what it is. Okay? If you do, let's look down at C. The correct answer is B. Let's look at C. Is this going to be larger than 5? This is actually a very, very small number. 0.48 divided by 5 is like 0.00 or 0. I don't know how many zeros. It's a small number. Okay? This number, though, is like 10.47 or something. This is the correct answer. And here's why. I always have people that struggle with